All right, everybody. Wanted to spend a couple of minutes talking a little bit about unit conversions and factor label method. I know this is something that you did a whole bunch last year in chemistry class. All of your mass mole particle conversions, all your stoichiometry problems basically involve factor label method. Hopefully you learned how to do it correctly last year in chemistry. I know certain chemistry teachers are more persistent, more insistent that you do it a certain way than other ones. I don't really care what it looks like when you're doing these conversions as long as you're doing them correctly. Um, you know, this is not going to be a huge focus of this class, but there are going to be times when we're going to have to convert from one unit to another. It'll show up on this test because it's part of your summer packet and we need to know how to do it and stuff like that. But later on, there's going to be a few conversions that we're going to use over and over and over again. And if you can do those quickly, that'll probably suffice. But I wanted to make sure that we've covered it so that we know what we're doing and how we're supposed to do it, et cetera, et cetera, et cetera. So remember, dimensional analysis, factor label method. Every number that we deal with in this class is a measurement, right? Some aspect of the universe, it has a quantity and it has a unit, okay? That's what we deal with in science class, a measurement of the physical world. Somehow, some way, that's what we're dealing with. But a lot of times, that value isn't measured in a unit that we want, or measurements aren't consistent in their units. We have some values that are measured in certain units, some values measured in other units, but we can fix that problem just doing a little math to get the number in the form that we desire. So, to convert a measurement from one unit to another, we multiply the known quantity and unit by a conversion factor. So, real basic form. We start off with a measurement in the quote-unquote wrong units. Not that it's wrong, it's just not what we want, right? So I use wrong in quotation marks. It's not really wrong, right? Then we multiply that value by a conversion factor. And we'll talk about conversion factors in just a second, right? And then we end up with our unit or our measurement, because remember, not unit, measurements in right units. Okay? Because one thing to consider here is that we're not changing the value of the measurement. It's still the same distance or the same mass or the same speed. We're just changing the way that we measure, or not measure it, sorry, wrong term. We're changing the way that we characterize it, or the way we represent it. Remember, it's the same measurements, it's just a different characterization, different representation of that same measurement. So, conversion factors. The correct conversion factor is going to cancel the units that we don't want and give us the units that we do want. Something important to remember. Conversion factors come from equalities. Let's see if it'll straighten that out. Nope, won't. Conversion factors come from equalities, which means that the two parts of the conversion factor are equal. The top and the bottom have to be an equal amount of distance, an equal amount of mass, an equal amount of force, whatever it might be. That means that every equality can yield two conversion factors. For example, we know that 1 foot is equal to 12 inches. That can give us two conversion factors. If we start off with something in, 67 feet as our measurement, right? Time sign fraction bar, we're going to have feet on the bottom, and we want to convert that into inches like that, right? But if we had measured something originally in inches, like 144 inches, right? Time sign fraction bar, inches go on the bottom, feet go on the top. This equality right here, the 1 foot is equal to 12 inches, can be used to fill in this conversion factor, but it can also be used to fill in this conversion factor, right? Because they're equal, it doesn't matter which way we flip them, right? What's on the top, what's on the bottom, this is the same value. And more importantly, it's 1, right? Because you have the same distance on the top and the same distance on the bottom, which means you're taking your original measurement and multiplying it by a factor that is equivalent to 1, which means we're not changing the actual amount of distance, We're just changing the way it's represented. Something to keep that in mind. While we're doing these conversions, we're not actually changing the amount that we measured. We're just changing the way it's represented. A couple of examples. So, yeah, this goes through the steps. If you want to pause and read it, you can, but I'm just going to show you how to do it because you should all be familiar with it at this point in time. All right, first problem. Convert 179,800 seconds to minutes. If you want, just press pause right here, do it real quick, and then you can come back and watch me, or you can just check out the answer. But I'm going to do it here in a second. So if you want to, press pause. I'll come back in a couple of seconds and show you how to do it. Okay, so we always start with the unit that we have in the wrong, or the measurement we have in the wrong unit. Not that seconds is a bad unit, it's just not the unit we want. We want this unit, or we want this measurement of time in minutes. Okay, so that's our desired unit. But right now we have it in seconds. So we start off, take our measurement with wrong unit, time sign, fraction bar, right? Then on the bottom of that conversion factor, I always teach it that we start with the units because we got to make our units cancel. Then when we follow the units, we can fill in the numbers real easily and it'll be good. All right. So if we want seconds to cancel here, this is on the top of a fraction. Remember, we can put any number over 1 and turn it into a fraction. And that means that, this seconds unit is on the top of this fraction. So we'll put seconds in the bottom of this fraction, right? Because now if we have something on the top and something on the bottom of two fractions that we're multiplying, we can cancel them out. On the top of this conversion factor, we want our desired unit. We've already established the fact that we want this answer to be in minutes. So we put minutes on the top here. Okay? Then it's a matter of filling in numbers to make sure that the top and the bottom are, in this case, an equal or an equivalent amount of time, right? You should know that 1 minute is equal to 60 seconds, right? That's the same amount of time. So now it's just a multiplication problem, right? We're multiplying two fractions together. So you multiply the tops, you multiply the bottoms, you divide those values, and you end up with a number, right? Also, because we're multiplying the tops, multiplying the bottoms, that means that we can do some unit canceling, right? Seconds on the bottom, seconds on the top, we can cancel those seconds. We're left with minutes. And when you run that through your calculator, oh, that's not the one I wanted. Never mind. When you run that through your calculator, you end up with this, okay? 2,996.66666666666, right? But sig dig wise, we round that to 4. Why 4? When we're doing conversions, our answer should always have the same number of significant digits as our original measurement. Why? Remember, we're not changing the amount of time in this case. Our measurement, our original measurement, left us with 4 significant digits. Remember, significant digits are based on the uncertainty of the measurement. If our original measurement left us with 4 significant digits, and we're not changing the amount of time, we're just changing how we represent it, our converted value should have 4 significant digits as well. Quick summary, however many significant digits your original number has, your converted answer should have that number of significant digits as well. All right, next. Each conversion factor should cancel out a unit from the previous measurement. For example, same amount of time, right? 179,800 seconds, but now we want to convert it to days. So like I said, I always teach to do the units first. So in this case, right, we can think of this as 179,800 seconds over 1, right, if we want to make it all fractions. So then, first conversion factor, we should have seconds on the bottom, right? And then we'll go minutes on the top. Okay? Now, we can do this in less than 3 steps. I'm just going to show you, make sure if we go multiple steps, all right? So the next conversion factor, if we look here, right, seconds on the top, seconds on the bottom, those two will cancel, so that's good. But we don't want our final answer in minutes, we want it in days. So we're not done with our conversion factors. The next conversion factor should have minutes on the bottom. Why? Because there's a minutes on the top of a fraction over here, and we want minutes to cancel, because we don't want our final answer in minutes. So if we go minutes, and then we'll put hours on the top of this one. But still, we don't want hours, right? We want our final answer in days. So we got to go one more conversion factor. That conversion factor is going to have hours on the bottom because we're trying to get rid of that hours. And then we can end up with day on the top here. Now it's a matter of filling in numbers to make sure that in our conversion factors, the top and the bottom are an equivalent amount of time. Not necessarily each conversion factor has to be an equivalent amount of time, but the top of one conversion factor and the bottom of that same conversion factor have to be the same amount of time. So we go and fill it in 1 minute, 60 seconds, because that's an equivalent amount of time, right? 1 hour, 60 minutes. These two are the same amount of time. It's not the same amount of time as the previous conversion factor, and that's okay, as long as these two are the same amount of time. Because remember, that really equals out to 1. So we're multiplying that original measurement by a factor that is equivalent to 1. And then 24 hours, 1 day. Once again, these two are an equivalent amount of time. And yes, I realize that there's not exactly 24 hours in 1 day. If you're thinking to yourself, hey, there's not. It's a little less than 24 hours. Yes, that's true, and I know that. But I know we're just going to go and make this simple, okay? Anyway, these two are an equivalent amount of time. These two are an equivalent amount of time. These two are an equivalent amount of time. Therefore, we can run those through, which means we're multiplying this original measurement just by a factor that's equivalent to 1, equivalent to 1, equivalent to 1. It's the same amount of time. We just represent it in a different measurement. So when you run it through, there's 3 conversion factors. You end up with this 2.081 days. Remember, 4 sig digs in this original measurement, 4 sig digs in this final measurement. Okay? Last one, and this is one that gets kind of confusing for a lot of people. Okay? Here we have a derived unit. We have a unit on the top and a unit on the bottom. They're measuring different things. Miles measures distance, hours measures time. All right? You can't do this conversion in one step. You got to do the time separately. You got to do the distance separately. Okay? So convert 65 miles per hour to meters per second. This is one that we're going to use kind of a lot in this class. So if you remember how to do this one, hopefully that'll serve you well throughout the rest of the year. Okay? So start off with the units, but like I said, you got to do distance separately from time. So I'm going to start off with the time because that one's kind of easy. All right? So we'll start off with 1 hour, but the important thing to remember is if you have 65 miles per hour, that's the equivalent of 65 miles every 1 hour. So if you write it as a fraction, 65 miles over 1 hour, that's going to help you properly set up these conversion factors, at least from the unit standpoint. Okay? So start with the time, right? In this conversion factor, we're going to go hours on the top of this conversion factor. Why? Because hours is on the bottom of this original measurement. We want to get rid of the hours, so we got to put them top and bottom. We got to put them opposite of one another, right? Now, I know, and hopefully you'll know after this, that there are hours you can go straight to seconds, right? We didn't do that on the last problem, but there is an equivalent number. Oh, sorry. Hit the keyboard while I was leaning forward. Oh, no. What happened here? Oh my goodness. There we go. Okay. All right. There are an equivalent number of seconds that equal 1 hour, and I'm going to show you what it is in just a second. You can probably figure it out real quick if you're thinking about it, okay? But if you know that conversion, that'll make it go quicker. Remember, these two time factors have to be the same amount of time, right? You don't have to go from seconds to minutes to hours. If you know how many seconds are in an hour, or if you know how many seconds are in a day, you can do that in one step, okay? So this conversion factor is going to take care of time. If we kind of jump ahead, right, if we have an hours on the bottom and an hours on the top, those are going to cancel, right? And that's good because we said we wanted our final unit in meters per second, which if we rewrite it, looks like this, meters over seconds. Where are their seconds? Seconds in the bottom of this fraction, and that's where we want them in our final answer. So let's keep it that way. All right, now let's do the distance. Let's kind of skip this conversion factor right now. Here, I'll do this for you, okay? Just so we can kind of think about it here, all right? Let's see if this will work, okay? I'm going to just cover this one up for a second. Let's forget it's there. We'll bring it back later, but let's do the distance now, okay? So the distance, we're trying to get into meters, right? So this first conversion factor is going to have miles on the bottom. Why? Because we're trying to get rid of miles. Miles is on the top of this fraction, bottom here, right? I gave you an equality right here in the problem that 1 mile is equal to 1.6 kilometers. So I can use that equality as my first conversion factor, miles to kilometers. And if we fill in the number, right, 1 mile is equal to 1.6 kilometers, okay? But we don't want kilometers, right? We want meters. So that means we got to have another conversion factor with kilometers on the bottom of this conversion factor. Why? Because it's on the top right here, and we want them to cancel. And then if we put meters on the top of this conversion factor, there is an equivalent distance that we can measure in meters and kilometers. And hopefully you know by now 1 kilometer is equal to 1,000 meters. Okay? And then if you look, right, if we jump ahead a little bit, miles on the top, miles on the bottom, kilometers on the top, kilometers on the bottom, we're left with meters on the top of a fraction, and that's good because in our final answer, that's where we want them. So let's get rid of this box that I put in to hide the time factor right now. Let's fill in the rest of this conversion factor here. Okay? 1 hour is equal to 60 minutes, and there's 60 seconds in a minute, so 60 times 60 is 3,600. If you didn't know that, it's okay. You can do it each time, or hopefully I just told you and you'll remember it. So now all the units that we want to get rid of are canceled, and the only units that we have left are a seconds on the bottom and a meters on the top, and that's what we want. So run it through, right? There it is, and we end up with 28.9 meters per second. 3 sig digs in our original measurement. Okay? All right, hopefully that works for you. Quick little run through. Monday in class, we will talk about some of those conversions. We'll do some with metrics. We'll do some with just regular units, kind of like we did here, just for some practice. And then hopefully we won't have to talk about this anymore for the rest of the year because you'll have it all down. All right, see you in class on Monday.